So hello everybody and welcome. So it's past 2 right now, so we're gonna start. So many thanks for your time and availability for this webinar dedicated to model and design a compressed air network using BIM. First, I hope everybody is fine and that your relatives and families are doing well. To introduce myself, my name is Gaël Le Carrère. I'm 29 and I've been working for Parker Transair for 3 years now. I first studied in our facility of Terrassa near Barcelona in Spain as what we call a VIE. It's a type of French contract. And then I moved to our headquarters in the city of Rennes in France. About what I do, I'm a project support and BIM specialist. More so, I'm part of the project support team here in Rennes. In the project support team, our main duty is to provide a free of charge service to our customers to help them quote their project through design and sizing of installation, bills of material, drawing, technical advices, etc. We are the technical guys, to make it simple. Regarding specifically me, I'm also in charge of the BIM for Transair with its development and communication. That's why I'm here today with you. We decided to offer you this presentation to give you an overview about how to use our template in order to model a compressed air network in BIM, from the very design and sizing of the installation with the basics of compressed air to the drawing inside Revit using our dedicated template. BIM is a growing process all over the world, taking more and more importance in building projects. So we wanted to give you the insights to get a better understanding of our template. I really hope it will be useful for you, and I obviously remain at your disposal for any questions. There will be a question and answer session at the end of the webinar. You can also, if you want, to write them in the dedicated windows inside the Zoom application, and I will be answering them at the end of the presentation. If you have any further question or inquiry, you can also contact me or email me. You've got my detail just right here. You can take a print screen if you want. I will give you my contact detail at the end of the presentation again. So to start the presentation, first I'm going to talk about Transair and give you a little presentation about who we are. Then I will talk about what is the main part of a compressed air installation. And then I will speak about our template and give you a quick presentation of it. So these 3 parts are going to last roughly 25 minutes. And then we will have the big part of the webinar, which is the case study, with first some rule of sizing and some basics about compressed air, and then the drawing inside Revit. That part is gonna last 25-30 minutes. So first, Transair presentation. During this part of the presentation, I will, as an introduction, give you a global overview of what is the Transair system. The idea here is not to provide you with a sales-oriented presentation, as it's not the aim of the webinar. I will just give you the key points about who we are and what kind of products we offer to our customers before going further on the BIM and Revit part of the webinar. In order to summarize who we are, I would say that Transair is an activity from Parker Group, which is dedicated to the manufacture of distribution systems for industrial fluids. In other words, we can say that Transair is a modular and innovative pipework system, which is totally engineered for the distribution of compressed air, vacuum, inert gas, and other industrial fluids. Our activity was first launched in France in 1996, and we have been since that time pioneering and leading the market for industrial fluids modular pipework system. We have 4 sites of production in France, but our product is stocked worldwide by Parker Transair subsidiaries and also distributors. All our industrial process is totally mastered and controlled in order to comply with most exigent standards and certifications such as ISO 9001 and 14001, for example. If we could define our offer by 4 specific points, I would say that first, we offer the best compromise between safety, rapidity of installation, and modularity of the system. Second, We always innovate by offering our customers the last innovations available on the market, such as BIM libraries, sensors, specific products, etc. Third, we provide a lot of technical assistance to our customers in order to provide added values on projects. Fourth, we guarantee some important savings for both contractors and end users. Regarding the three kinds of industrial fluids that Transair range is able to transport, we can say that the first one is compressed air. Compressed air is very common energy source within industries, and it's mainly used to supply pneumatic tools or machines. One interesting point about compressed air is that compared to other utilities, it's generated on site, meaning that the quality of the compressed air and its generating costs are in the end and control of the end user. Regarding vacuum, it's also quite common utility used by industries. Instead of being connected to a compressor, like the case for compressed air, the pipework system is connected to a vacuum pump from the machines. Vacuum is generally used for the handling of heavy products, the evacuation, the evisceration, wrapping processes, and packaging processes. Finally, we have the neutral gases, such as nitrogen, argon, CO2, that could be distributed by Transair for specific application who might need it such, as laboratories, welding, or even blanketing applications. These fluids are easy to produce from either the atmospheric air on site or from high pressure bottle. Just a few words regarding Transair aluminum range specs, as it is the one that we are going to use today for the BIM demonstration. Transair is a modular and quick to install pipe system for the distribution of the following industrial fluids: compressed air, which could be dry, wet, lubricated, and breathable; vacuum, up to 10 millibars absolute pressure; and neutral gases, such as I've just said before, nitrogen, argon, dry CO2 mainly, and their mixes. Regarding diameters, we provide a full range of pipes and associated fittings from 16 millimeters up to 168 millimeters, which allows us to cover any kind of project from a garage to huge industries. Our range of service is from, our range of service pressure is from 10 millibars absolute pressure to 16 bars. Our range of temperature is from minus 20 degrees Celsius up to 85 degrees Celsius. And the system can be installed in any types of environment: exterior, compressor room, saline, etc. Last, in the presentation of Transair, I will speak a little bit about our connection technologies. I will not go too much into detail regarding them. However, I will just say that the bigger the diameter is, the more safety measures we have to take in order to guarantee the security of our customers. In order to provide the best compromise between safety, modularity, and quickness of installation, there are 3 different technologies of installation according to the diameter you want to install. All these technologies will always provide a significant amount of time for the installer, but guaranteeing the safety and modularity for the end user. So regarding the technology, so for the small diameters, we have a Greek pin ring technology. On top of that, for the intermediate diameter, we have what we call a snap ring. And for the biggest diameter, we have a lug and clamp technology. Now I'm going to go about what is composing a global installation. What you need to know about a global installation in industrial fluid is that it's composed of many different machines, with each one of them having its own purpose, going from air treatment with filters that are going to remove dust and contaminant from air, to receivers to store the air, on more specific generator in order to generate specific gas like a nitrogen generator, etc. In a compressed air installation, more specifically, we recognize 2 main parts. First, the production, where we are going to generate the compressed air. with some specific characteristics such as flow rate, pressure, and quality. And the second part is the distribution network, which is there to make the link in between the point of production and the point of use. First, I'm going to talk about production. So I'm going to go over the different elements which are composing a typical compressor room. First, we've got the compressor. Not much to say about it. Everybody knows how it works. So we're taking air from the atmosphere, from the environment, and we compress it. Working pressure in our range, in the range of Transair, usually between from 5 to 16 bar. The technology on this type of compressor is mainly screw technology, so screw compressors, because screw compressors in that range have a really good efficiency and they're not too noisy. We distinguish two types of screw compressor: fixed compressors, which are either working 0% or 100%, and variable speed compressor, which can, when you can manage the output, for example, 80%. Then we have the receiver. The receiver is usually between the compressor and the air treatment after it. The receiver is really important as it gives a better efficiency and stability to the system. By having a receiver before the air treatment, we allow for a really steady flow of air through the air treatment in case the compressor is not working. If the compressor is not working, the air receiver would have stored air inside him and will still deliver a steady flow. The receiver is also the first element that is going to allow for separation of residual condensate. A little word about condensate. So as you know, there is water inside the air we breathe. And when we are compressing that air, the water is going to liquefy and turn into liquid water, which is something we don't want. The receiver is the first element that is going to remove that water. Then we're going to go with air treatment. So there are two main elements in the air treatment part. First one being filters. Same really easy role. They are there to limit the concentration of undesirable contaminants like water, oil, but also particles, dust, and also more like biological, other like virus, bacteria in some case. There are several types depending on the filtration level. I'm not going to talk more about them. They're just filters. Then the second element of the air treatment, the dryer. As I've said before, there is water inside the compressed air and we need to remove that water, because that water can cause corrosion problem, but also with the oil contained in the compressor and contained in the environmental air the compressor is using, they can mix to form aggressive water emulsions. So the role of the dryer is to decrease the water vapor and oil content, remove the water from the compressed air. We distinguish two types of refrigeration dryer, two types of dryer. The first one is the refrigeration dryer. There, the principle is really easy. It's like the fridge we all have in our kitchen. The air is going through a cold heat exchanger and the water is liquefying at its contact. The dew point on this type of refrigeration, on this type of dryer, is +3 degrees Celsius. The dew point is an equivalent of quantity of water inside the air. Second technology, second type of dryer, it's what we call an adsorption dryer. There we are on a completely different technology. We are using what we call a desiccant filter to remove the water. A desiccant filter is basically a tube filled with tiny balls that have the property to attract the molecule of water. What we are doing with that type of dryer is we are going to get the air through the pipe, and the air at its contact is going to be released of its water. The balls are going to attract the water, meaning that at the end of the pipe, the air is completely dry. Those type of dryers, they're working with 2 rows of pipe, as you can see on the picture. When one row of pipes of desiccant filter is removing the water from the air, the other one is in what we call regenerating mode. It's basically emptying its water. And when the first row is completely filled with water, they simply switch. The dew point on this type of dryer is -70 degrees Celsius, which is almost no water. If you want the best quality with no water inside your network, this is the type of dryer you're going to need. Last element of the compressor room is the oil and water separator. In the condensate you're going to extract at the different stage of the compressor room, they're going to have hydrocarbon particle in them. Actually, they can go up to 5%, which is too polluting. The separator is there to reduce the oil content of the condensate. in order to reject them to the wastewater. The separator is going to separate the oil, the water. We're going to keep the oil and release the water in the wastewater. Regarding the distribution network, is there, as I've said before, to make the link in between the point of compression and the point of consumption. Its energy impact is often minimized to the detriment of the compressor. The compressor is usually the most expensive part of a compressor network, but it's not because the network is cheaper than the compressor that you have to undermine its effect. The distribution network, it must cover all consumption needs with a minimum pressure drop, because if you have too much pressure drop inside your network, you're gonna have to rise up the output pressure of your compressor. And just a little number for you to know, if you increase the pressure of your compressor by 1 bar, it's resulting in 7% more consumption of electricity. So it can add up really quickly. You want a network that is which has an optimal ceiling, because if your network is leaking, you are producing compressed air and you're not using it, it's a complete waste. You want a sustainable treat quality. As we've just seen in the compressor room, we have different elements to treat that air, and we don't want the network to decrease that quality. Last, you want a network that is safe, reliable, and efficient over the years. You don't want your network to be obsolete after just a few years. You want something that is going to last for many years. In a network, more so, we distinguish 3 main parts. First, the header, which is the part in between the compressor room and the network. The main network itself, with usually loop and lines. I will talk more about that afterwards. And the drop, which are there to link the network and the point of use. Now I'm going to talk about our template. So Transair is a industrial manufacturer, and initially we used to have our plan and drawing in typical 2D CAD drawing. But with the BIM rising up all over the world and more and more people using it, we decided to invest inside the BIM in order to be able to interact with that process. Doing so, we went to our partner BIM&CO, which is part of the Transair Group, which is a longtime partner of Transair, in order to design and create our own template. A template is simply a catalog for the software you're using it for. In our case, it's Revit, because Revit is right now the biggest software on the market. So what we call a template is a Transair catalog for Revit. That template, it exists in 2 versions. First version is a BASP ISO, and the second one is NPT-ANSI. Both those templates, they are available on Revit 2017, level detail 200 and 400. They are available on Revit 2017, is meaning that they are not compatible with previous version of Revit. On Revit, the way it works, the compatibility is always ascending. You cannot go backwards. Both those templates, they only contain the aluminum range. There is no stainless steel inside these templates. And they are each one of them based on their own catalog. So BASP ISO is based on the Europe, Middle East, Asia catalog, and the NPT-ANSI is based on the North America catalog. That template, it's free to download on the website of BIM&CO, our partner. I'm going to show you how it's looking like. So the address is bimandco.com. When you arrive on the website, you are on that page. You're going to need to create an account to register on the website in order to download your object. So it's completely free and it's only taking minutes. You just file your name, password, mail address, etc. Once you created your account, you're going to be able to search for BIM object and download them. You're going to click on the search for BIM object case, and you're going to arrive on the library in BIM&CO. You can either type here in search the object you're looking for, or a brand, so it can be Transair or it can be an elbow, or you can go directly on our manufacturer's page. Once you're on that page, you can select Transair. And there you arrived on our manufacturer's page. And there you have all our objects, from the template here to every individual object, from wall bracket, valve, etc., etc. And if you want to download something, let's say a template, you just click on the object and you press download. It's as easy as that. But what is inside the template, you're wondering? So the template is composed of different families, actually it's 3. First, we have the pipe fittings, then the pipe, and last, the pipe accessories. So the pipe fitting, it's all what is parametric with predefined element with like automatic creation and diameter change. In that category, in the fitting, we usually have T's, elbows, end cap, cross connectors. Then we have the pipe. Much better to say about that. Piping is available in the 3 different colors, blue, green, and gray, and in every diameter. Last, we have the different accessories, which doesn't have all the automatic creation, diameter change, and that the fitting has. You need to do it by yourself. There we have mount stud, wall bracket, but also valve, for example, which in Revit are considered as an accessories. For example, you cannot have valve as a fitting because for Revit it would be wrong. You still have to comply to the way the software is working. And for each one of these objects, it has its own size, so its own data, so size, weight, temperature and pressure, identification data, etc. We also have the routine preferences for pipes, so which allow, for example, the automatic creation of the elbows and teeth, and also the automatic bill of material for accessories and fitting in one part and piping on another part. When you download the template, you're going to open it on Revit and you're going to end up on that page. So I've just downloaded the template in order to save a bit of time. So you arrive first on a page with some specification about Transair. And then you can move on the different views. So each template has an example, as you can see here, with a little bit of network compressor room and a network. We have some, so we have a ground view. We have some 3D views also of the network with some different layout in order to show you how it is done. So here we have some tags put on the different object, etc. Here on the side, so in the families part, we have, so my Revit is in French. We have the accessoires de canalisation, so accessories here with wall bracket, quick assembly bracket, etc. We have the piping in the 3 colors. And last, the fittings with elbows, cross, connectors, etc., etc., etc. If you go on the piping, for example, we also have, as I've just said, the routine preferences. So this is where everything is configured in order to have an elbow appearing if it has to, a cheese, etc., etc. Last, about the template, we have, so as I've just said before, the bill of material. So there is one for fitting and accessories. So it's in with product code, description, etc. And one for the piping with the length. So this is what you get when you download the template. We will use it just after in the case study. Now I'm gonna go over the case study, so which is gonna be the main part. So first I'm gonna go under, so the rules about compressed air, it's gonna be compressed air 101, if I might say. And then we will use what you just learned to size and design the network and draw it inside Revit. So first, physics 101, as I might say. First, there is 2 different network configurations regarding compressed air. First configuration is what we call the straight line. It's suitable for really simple installation with close points and low precision. It's simply a line and we connect the different point of views on that line. The main advantage is that it's cheap, but be careful because in that configuration, you can have pressures like at the end of your line. And if you want to do any modification or upgrade on your network, it can be really costly. The second configuration that we prefer to use is what we call the loop. The loop is what we use in almost every project with numerous takeoff point and area. The advantages are we have a standardization of flow rate, a potential because the air can come at one point by different ways. we have a potential diameter reduction because a loop can transport a lot more air than a line. We're gonna see that just after. And last, we have a really good network modularity and scalability. Because your network is gonna be separated for each area with its own loop, you can have a better maintenance behind that with a couple of valves to isolate the parts. Same goes with your process, etc. Better modularity, better scalability of your network. So in almost every project, we go for a loop configuration. Straight line is only for small projects, 4 or 5 pounds max. Regarding the reduction of diameter, as I said, here we have a quick example where I do compare a line and a loop. In that case, we have a flow rate, Q, at the beginning of a line and at the beginning of a loop. In the line, you can see that the flow Q is going to be constant during all the way, and we're going to have a pressure drop. But in the case of the loop, that flow rate Q is going to be divided by half at the entrance of the loop. It's going to be divided by half at the entrance of the loop, meaning that at the end, you're going to get your flow rate Q like you would have the line, but because your flow rate would have been divided by 2, your speed will be divided by 2, and the pressure drop will be divided by 4, because as I remind you, pressure drop is a result of the speed by the square of the speed. So using a loop, it's really good for pressure drop and in the end, transporting more compressed air. A couple more things to know about compressed air. So the two most important data are first the flow rate. So in Europe, it's expressed in normal cubic meter per hour. And in North America, it's usually a SCFM. So flow rate, it depends on the machines you're using. On the types, is it just simple tools or really big machines that consume a lot of air, the numbers, and the use. Are they going to be used every day, only during the afternoon, during the night, etc. When it comes to flow rate and design, we always go for the worst case, meaning when the most machines are going to work. Regarding pressure, it depends on the machines only. The pressure is usually around 7 bars, but it can depend. Some machines can have a different pressure in between them. In that case, you will need to have a really good look at the configuration and how the project is. Because for example, if you have one machine at 10 bars and all your 10 machines at 7 bar, it doesn't really make sense to have your whole network at 10 bars for only one machine. It's a lot smarter to have one network at 7 bar and maybe use a second network or a booster just for that single machine at 10 bars. So pressure is usually the same for the whole network, but when it starts to have different pressure, you need to really have a good look at it. Last, about practical things to know about the network. You also going to need drain points on your network in order to get condensate. You never know if your dryer is under maintenance, for example, and you're not removing the water as good as you should. Water could go in your network, and then you want to be able to remove that water in this particular case, or if you're stopping your installation and restarting it. Same goes with valves. You want a couple of valves in order to isolate the different parts. And eventually you can use a monitoring system to check out on your network. A couple of things to know about networks. So main network, as I just said before, we go for the loop almost all the time. Regarding velocity of the fluid, we advise to never go above 10 meters per second. That limit can change depending on the cases, but in a general manner, we go for 10 meters per second max. This is the value you need to remember. Regarding pressure, the commonly accepted pressure is 7 bars. Most of projects are working in 7 bars. This is really common. Regarding the pressure drop, we don't want more than 5% from the production to the point of use. And last, I remember you that 1 bar extra at your compressor, it's ended up with 7% more consumption of electricity. In order to do this calculation regarding the flow rate, the length of the project and everything, we are using a tool that we call the Transair Flow Calculator, which is a free software that is available on request. You come to us, you ask us to give you the software, and we'll give it to us. You can come by mail address, for example. What we put, you have a couple of input data to enter. So first with type of fluid, the pressure of the network, the flow rate, let's say 500, the length of your network, a max pressure drop, either being absolute pressure drop or a percentage, let's say 5%. The type of the network, so we've just said before, either a straight line or a closed main ring, a loop, and the range, aluminum or stainless steel. You can also change the unit if you want. Here I'm using the European unit because it's what I'm used to, but you can go for pressure, you can go with PSI, flow rate, you can go with SCFM, etc., etc. Same goes with language. Once you did get all your input data inside the software, you just go size, diameter, and the software is going to calculate what you need for your project. In that case, for example, I will need a diameter of 50 millimeters for that loop. In that precise configuration, 7 bar and 500 normal cubic meter per hour. This is what we're going to use to size every part of the network. Now let's go inside the case itself. So we have a building that I did drawn on Revit. So I've got the model of the building. There you have it. So it's composed of different parts. You've got so workshop and storage part here with no compressed air point. The office with a desk and everything, a warehouse. We've got the compressor room here on the right side and the boiler room just under it, which are not good. We are not going to use today. In the middle, we have the most important part, the production part, where we have all our point of consumption. You can see that we have a bunch of points surrounding the area in green, with each one of them being at 30 cubic meter per hour. And the 8 points in the middle are divided in 2 lines, with each point being at 45 cubic meter per hour. The building, so the production zone, it's 30 meter by 50 meters. There is 10 meters in between each line here. From then, we're going to need a couple more hypotheses in order to start to do a sketch of our network and to size it. Those hypotheses are going to be a pressure. Here we only have a flow rate. Regarding pressure, we're going to go with 7 bar, which is the common thing accepted in this area. Fluid, we are in with a compressed air installation, so we're going to go with compressed air, with air. Simulation factor, simultaneity factor. Here, in the worst case, we are going to consider that every machine can work at the same time, meaning that we need to be able to supply all of them at once. So the total flow rate, when we are going to do the sizing, is going to be the total flow rate of all the points, meaning in our cases, the total flow rate is going to be 660 cubic meter per hour. Last, the height of the network, we're going to go with 6 meters. It's going to be only for drawing in Revit purpose. So first, we are going to do a sketch of the network. How we're going to supply our different points inside the building. As I've said before, we really want to have a loop in order to have a backbone for our installation. We can see here all the green points are all around the area. So it makes sense to get a main loop around the area. Then we are going to need a header in order to supply that loop from the compressor room. And last, we need to supply the red point. Here, we can do something easy. We can just add 2 lines, which are going to be crosswise line, inside the loop in order to supply those points. And there you've got a network with a loop, which is going to be the backbone of your installation. And then the header to supply it, and the line to supply those other points not exactly under the loop. Now I'm going to do design. So now we're going to go inside Revit. So the way we're going to process, we're going to work on each part I've just said before. So first main loop, then the header, then the line, and finally the drop. We're going to do a quick sizing of the part in order to know which diameter we need to use. And then we're going to draw it inside Revit. First, I'm going to go with the main loop because this is the backbone. Inside, so we're going to go with, here you've got the input data that I reminded you. Total flow rate is going to be the whole flow rate of the installation, so 660 cubic meter per hour. Length, it's going to be 160 meters. So to remind you, the production zone is 50 by 30. Pressure drop, we're going to go with 3%. So this is something you need to know. Whoops. When it comes to loop, as I've said before, we don't want more than 5% of pressure drop in between the point of compression and the point of use, meaning that inside the different part of your network, you need to have less than 5%. In the loop, as it is a backbone and where you're going to have most of your flow rate going, we are going to allow a good bunch of that 5% pressure drop, and we usually go with 3% pressure drop. So just so you know, I'm going to go with 3% pressure drop in that case. Network is going to be closed main ring. We are inside a loop, and we're going to go size diameter. Here we can see that the diameter we are going to require is 50 millimeters. It's going to allow for a maximum flow rate of almost 900 cubic meter per hour, meaning that if we want in the future, we can add some extension on that network. And we have the velocity of the gas here, which is 6.6 meter per second. You also have the pressure drop right here. So we go with diameter 50 millimeter. Now to draw it inside Revit, we're going to use, so I'm going to introduce you to the pieces we're going to use. We're going to need some piping, obviously, elbows for the corner, and I'm also going to show you how to use a pipe-to-pipe connector. I'm going to come back to the template that I've opened. So I'm going to remove the example in the middle in order to link my model inside the template. So here I've got a clean template. I'm going to go into insert and I'm going to link the Revit file I have, so my industrial building. I'm going to go on base and open. And I'm going to put the network, the building right here. I'm going to fix it in order for it to not move. And there we have, inside our template, we did import the model of the building. And it's, as you can see here, it's linked here inside the template. Now we're going to start drawing. So we're going to go into our ground level. And in order to start drawing, you're going to go into the system tab on top, piping. And then you're going to be almost able to draw right away. You're going to choose here in the property view the right color. So compressed air, it's almost always blue. We're going to specify the diameter. It's going to be a diameter 50 in our case. The 8, it's going to be 6 meters, as we said. We're going to apply that. And from then we can start drawing by simply clicking inside the model. And from there, we can create the loop. As you can see here, if I'm zooming in, so the pipe is appearing in blue. And if I click here, the elbow is automatically created because of the routine preference inside the template. I'm going to create the complete loop. And there you have it. Then you're going to have to, I'm going to push it in the surroundings of the zone. So the one easy way to do it is to use the annotation tab and to quote your project. So for example, if you want, so let's say 700, it's a really easy way to do. I'm not going to go do it for everything because this is not the purpose of this webinar. I really want you to show you how the templates work. So you do some annotation and you can have your main loop well placed. Regarding connectors, so as you can see here, so we can go in 3D view. So we have the building here and you can see the network here appearing in blue. Here you can see that line, it's a continuous line. There is no connector inside it. So the template is not able to automatically add the connectors inside the line. In Revit, a pipe is a pipe, and it cannot consider a pipe to be only of a certain length. If you want to have the connectors, you're going to have to add them manually. So you're going to go into fittings, and you're going to select, here in our case, we're in diameter 50, we're going to select the reference 6606, and you can simply add them on the network. So if you move close to your network, it's going to be attracted to it. You're going to click, and the fitting is automatically going to adapt to the right diameter. So here, a diameter 50, as you can see. And then same logic, you're going to have to use the annotation tab in order to push it and have it at the right length. Now this is the loop. We're going to go and do the header. So it's going to be the same thing regarding the header. We're going to have total flow rate is going to be the same. Length, we're going to go only for 10 meters because we only have to supply the right side of the loop, and then the air will go through it. Pressure drop, we're not going to go look into pressure drop because when it comes to header, speed is going to be the limiting factor. Because the header is going to be short, it will not matter if you have a small or a big pipe, because your spike will in any case be small, you will have a small pressure drop. So we always look, when it comes to header, to the speed of the fluid. I'm going to go with straight line, and I'm going to size diameter. And here you can see I let 3%, but at 3%, you can see that with the diameter 40, the pressure drop is not that high, but the speed is really high. It's above 10 meters per second. That's why we're going to choose the first diameter in order to have a speed under 10 meters per second. In our case, we're going to be a 63 diameter. Regarding the elements we're going to use to do the header, so we're going to need elbows and piping. We're going to need a mouth stud fitting in order to connect this Transair system to the outlet of the compressor room. And we're going to need a T and a plug-in reducer in order to connect the header on the loop. Back to Revit. I'm going to go again in my ground floor view. The compressor room is here, as you remember. Here we can see on the 3D view that that part here, it's the height of this part is a lot lower than the height of the main area. So we're going to have an angle here. The pipe is going to first go horizontally and then vertically inside the loop. We're going to do the same thing. We're going to go into system, piping. This time we're going to select a diameter 63. And the height, we're going to go only, let's say, for example, 2 meters. And I'm going to start drawing on the plan. I'm clicking on the loop. In that way, Revit is going to calculate in order to get the angle with the elbow and the T. One thing I want you to be aware of is Revit is a really powerful software, and it can create PCs that does not exist. In this case, for example, it's going to try to create a T, but that T does not exist. In the Transair template, we have identification data just right here called product code. When a piece is created that does not exist in the catalog, Revit is going to give us a product code which is none. You can also see it, for example, on the 3D view here. We have the red panel appearing saying there is a problem, that piece, it does not exist. That product code also, you can track it inside the bill of material. Here you've got a non-product code appearing, meaning there is something wrong. So always be careful when you're drawing. Revit is good, but it's never going to be as good as you. I'm going back to the level 0, and I'm basically going to draw the connection between the header and the network. I'm going to remove that T because it's wrong, and we're going to do manually. We're going to create a diameter 63 T and then the 2 plug-in reducer on each side of that T. I'm going to take the piping coming down, and I'm going to right-click and do drawing piping. I'm going to select, here we have the right diameter, 63, and height, we're going to go with 6 meters in order to be at the same level as the loop. Revit is creating an elbow. I'm going to press the little plus here in order to convert that elbow inside a T. And there you have it. You just need to connect the piping diameter 63 to the piping diameter 50, and Revit is automatically going to add the plugin reducer. And as you can see, the plugin reducer has the right product code. The T here has the right product code, meaning it's good. Those objects, they do exist. And I do the same here. Same if you want, you can just manage your plugin reducer in order to get them closer to the T. Last, we need to add the mount stud fitting, so reference 66.5. So another really quick handy tips you can use is Control F, Control Find shortcut inside the project browser, and you just tip the reference, and you're gonna directly goes to the reference of the products. In our case, 66.05. So I'm gonna select this one. And same as the connector, you just come close to the end of your piping, and the connector is going to go on top of it. It's going to automatically stick to it. And then if you want to move, no problem. So there's a problem because that one is not moving, as you can see. If I come back to the 3D view, here you can see we have inside our building the loop here, and there's the connection with the T, the two plugin reducer, and the header going horizontally inside the compressor room, and our melt stud here just hiding. Same thing about the line. We're gonna do a sizing. So the flow rate in the line, so if you remember, there are the two lines with each one of them having the 4 red points. Flow rate, it's gonna be only the flow rate for that line. So in one line, it can have 180 cubic meters per hour maximum. The length is going to be 30 meters. Regarding the pressure drop, we're going to have, usually most of the pressure drop, we want to have it inside the loop. So inside the line, we usually go for a really small amount of pressure drop. In that case, we're going to go with 0.5%. In our case, we're not going to be in straight line, because if we have a crosswise lines, it's going to be connected on both sides to the main loop, meaning that that line is going to be like a loop because it's supplied in both sides. If you want to go with straight line, is usually used for lines that are ending with a hand cap. So we go close main ring, and you can do the sizing. Here we need the diameter 40. Things to know about lines. So we usually go for 0.5% in pressure drop. If you're crosswise line, you are in a loop. If you are in a hand cap line, you are in straight line. The pieces we're going to use, we are going to use piping. We're going to use reducing teeth. I'm going to show you how to use the valve. And also, even if they are not used here, I'm going to show you how to use the vented head cap. Back to Revit. I'm going to switch to my level 0 floor, and I'm going to start drawing the two lines. So I'm going to choose the right diameter, 40, 8 is good, and I can just start drawing. I plug the line inside on the loop, and here you can see the T is created automatically, and this time it's a right T, not like the header. This reference, it's existing, so the T is good. To connect on the other side, you can either manually take the extremity of your pipe and connect it. Otherwise, you can go in modify here and use those little shortcuts here, those modified shortcut. And there is really the two handy one or the adjust one. You can adjust your pipe to go on the loop, and the T is also created automatically. I'm going to do once again for the other one. I go there, I put the T is automatically created, I connect on the other side, and the T is connected. Then if you want to align your line, you can either move them, or you can just stick them to your reference here, your reference line here. Regarding valve, so there are accessories, reference 4092. Same, I'm using the Control F shortcut. There is, as they are not fittings, but accessories, because in Revit, they are considered accessories. There will not be an automatic diameter change. That's why they exist in every diameters. As a connector, for example, if you go here, there is one connector for every diameters, because this one, it's adapting automatically. I select the right valve, diameter 40, and I put it on the line, and same as the mouse stud and the connector, it's simply sticking to the piping automatically, and then you can turn it if you want. Regarding hand cap, if you have some, I'm going to create a small piping here. You can either right click on the extremity of the piping and you just press the close the open extremity. The end cap is going to be automatically created, or you just select it from the family trees from the browser. Vented end cap, and because it's fitting, it's going to adapt automatically to the length. So you can see it just went bigger and it's sticking automatically. This is for the lines. Now, last part, the drop. We're going to go with the worst case. So the drop is the highest flow rate. There is the one with the 45 cubic meter per hour flow. Length, we're going to go with 5 meters. Pressure drop, same as with the header. The drop, they're going to be really, really small. So you want to go with the speed and not with the pressure drop. And network, it's going to be straight line. So I'm going with Transair flow calculator once again. Pressure 7 bar, flow rate 45, length 5 meter. We're going to be in straight line. I do the calculation, and we need a diameter 25. You can see that 16.5 would have done it. There is not much pressure drop, but the speed is a bit high, so we go for 25. We try to stick to that 10 meters per second. Regarding drops, there is also a feature really typical with compressed air. This is what we call the swan neck. Inside your network, as I said before in the rule of heart, you will need drain points on your network in order to remove condensate if you would happen to have condensate inside your network. A main feature of the drop is to have a swan net in order to connect your drop from the top of the network and not from the side, not from the bottom. Here at Transair, we have what we call a quick assembly bracket. They are basically a bracket which has an integrated swan neck in order to have an integral water retention inside the network. The water does not go inside the drop, it just stays inside the network. Those brackets, they allow for a really quick installation without any cutting of pipe, and we still keep a very high flow. Regarding the drop, we're gonna need a quick assembly bracket to do them, some pipe and elbow, and a wall bracket at the end of the drop in order to have our point of use. A few more words about drops. We also have in the European BSP template, we have a bunch of accessories like FRL for dry, damp, and lubricated air. We also have oil drill and recoil tubing, automatic safety couplers, valve, and milestone. Those accessories, they depend on your area. If you're in Europe, you're gonna have almost everything inside the BSP template, for example. If I come back to Revit, we're gonna draw a drop. First thing to know about the drop is the wall brackets. The wall brackets, the way they've been created inside the template is that they need a host to be able to be put. You can't put them like that in an empty area. They need to stick to a surface, to a plan. It can be either a wall, like here, and here you can see the wall bracket as sticked, or it can be what we call a reference plan. In order to create a reference plan, you're gonna need to go to architecture. Completely on the right part, you've got here reference plan, plan de référence, and you can draw a plan, for example, here. And on that plan, you're gonna be able to stick hosted accessories or elements. If I take my wall bracket once again, you can see here, I can just simply come next to the plan and it's gonna stick to it. Regarding wall bracket, you need a plan, or a wall in order to fix them. Now I'm gonna do I see the time gets really short, I'm gonna quickly do a drop. I'm gonna create a side view so you can see how it's appearing on the side. So up, I'm going there. Side view, section view, I'm gonna add it just next to it. I'm gonna increase the resolution, get a bit of color. And there we have the wall bracket. I'm going to add on top of my piping the quick assembly bracket, reference 6662. In this case, on the line, it's going to be a 40 to 25. Same, you just get close to the piping and it's going to be added automatically. You can either directly get your wall bracket just in the straight alignment of the wall bracket, or you can be just a bit on the side and you align it using same modification, the align shortcut. And you align on the wall bracket, the quick assembly brackets. Then that quick assembly bracket, you're going to need to turn. So here it's not on the good area, so I'm going to turn it and move it and rotate it around the pipe in order to have the swan neck on top of the wall bracket. Then you need to connect both of them with either you go on the assembly bracket, you've got the connector here, you can go right click, draw a piping. It's automatically by default here in the right color. And you can get close to the wall bracket. And here you can see there will be a little circle, a little purple circle appearing, which means it's going to connect to the connector of the wall bracket. And if I press here, you can see on the section view here that the Revit automatically creates the elbow and connect at the bottom. You don't have anything to do. Another way to do it is by either you can start your piping here, same, right click. You start drawing the piping going up. You start drawing piping going on the left, and you can use same, click on the piping, modification tab, the green tab, you go on adjust, and you can just get both pipes to just fit together, and the elbow, because of the routing preference, is automatically created. And then if you have, let's say 20 drops, you can do it, you need to do it again and again with either copy paste. Be careful with copy paste because sometimes copy paste does not keep the connectors here. For example, if I copy my wall bracket, my quick assembly bracket here, you can see that the pipe is continuing. It's not connected to that quick assembly bracket, resulting in a new system being created. Be careful with that. Now for the last part, I'm going to briefly talk about bill of material. So once you've drawn everything inside Revit, you're going to be able to extract the bill of material. But that bill of material, it's not the bill of material you're going to need for your to place your order, for example. You're going to need to do some changes to it in order to have it to have the right one. You're going to need to first calculate the number of pipe you're needing because Revit only gave us the length. You want to have a whole pipe for drops. You try to avoid to cut and use connectors inside drops. I didn't talk about it, but for fixing clip, you can go for 2 fixing clip per bar. Same if you did not add them manually, you can still add them right here. For connectors, same thing. If you did add them manually, you will have the number of connectors appearing in your bill of material. If you didn't, you're going to need to calculate them. One easy way to do it is the formula you usually use is 1 connector per bar minus 1. And for the pipe, if you have 20 pipes, you have 19 connectors. And remember, if you got a product called none, it means an object is not valid in the model. So yeah, the hour went by really quickly. So I hope it has been useful for you and you've learned a few things. So we're gonna start the question and answer session. I'm gonna release a quick poll right now. So about that webinar. So if you would be pleased to complete it, and then I will answer some questions if you have them. So regarding question, you're going to need to use the tab inside the Zoom application. So question and answer. So first question I have: how do you define air, compressed air in Revit? So I can really quickly show you. So the way you define air is by defining the system of the piping as compressed air. If we go inside on the piping here, we can see there is a HVAC and we've got system classification. We usually put compressed air inside the classification others. These classification systems, they are by default in Revit. You cannot change them. There is 9 of them, I think, and you cannot do anything about it. But then in other, you can create some type of system, and in that type of system, you're gonna create compressed air. Inside the template, we have some compressed air type system by default. So here we have a compressed air 7 bar. And if you have several systems, they're gonna have a number. The system, you can find them inside the, if I remember, system, it's F9 here. So you've got the system browser. And if you go in piping, you're gonna have your system appearing here and all the different numbers. So this one, it means they are not properly connected if you have different number. That's how you set up your system. And once one object in the system has a proper definition, the proper type, everything connected on it will take that type. I don't know if you have any other questions. All right. Yes, we'll be able to share if you want the PowerPoint with you. There is no problem about that. You just send me a request, so I have your mail address, and we can give you that. So here the air is already defined. If I tip, for example, a new system, if I click on the pipe here, the system, it's already compressed air. And if you need to change, you just click here on the type system in the property tab of the piping. And here you have all your system, you can see. So here we have vacuum, you've got, so it's in French, but like plumbing, gas, cold water, hot water, etc. That's how you define a compressed air system inside Revit. You just precise the type system here. Here, as you can see in that template, we already did set up 2 compressed air systems, one at 7 bar and the other one at 10 bar. Pipe support. So I think you're referring to the fixing clip, which are the 1697. They are not added automatically. This is a feature the template cannot do. You need a plugin to do that. So if you want to have the fixing clip, you either add them manually, and same, they're gonna stick to the clip. So here, this is not the right diameter. So the fixing clip are an accessory. You add them manually, or you just simply do your network without the fixing clip, and you just add them in your bill of material at the end of the project. Either way, but they are not put automatically. So using that template, we can also, yes, design compressor room. This is something we can do. It's a bit more complex, but yeah, it's perfectly able to do it. We do it regularly. I don't know if I have an example of what I could show you, for example. If I go, that webinar was really dedicated to the distribution network, not the compressor room. This is something we might do in the future for compressor room, because compressor room are usually bigger diameter, especially 3 inches or more. And when we have 3 inches diameter, we start to be with the clamp, and then it's another logic. You need to add clamp on top of another. So sometimes they can add them, so you need to remove them. It's a bit more tricky, but it's perfectly, you can perfectly do it. I'm looking for a compressor room I would have done, for example, if I have a PDF file for you to see. No, in Revit, I don't think you have fluid as a so regarding the compressed air as a fluid inside Revit? No, naturally it does not have it. It only has the 9 classification, but there are no type inside it. So you need to create your own type of system of fluid. We do add them inside the template, but if you need some more specific one, you just need to create them. You can just go inside here. I think it's here. You can just go under in the, so the piping system is just another family. Go in piping system, and here you have your system. So you can see here I've got compressed air. Just right click, you can just add a new system like that. The whole here, your canalization system, your piping system. I don't know if you have any more questions. I'm looking for. Ah, damn it. Yeah, so calculation with Revit is something you can do, but it's pretty complex. So we are not at that stage yet. So we prefer to use a Transair flow calculator right now. It's a lot quicker. But yeah, you could do it if you have a really well designed Transair template, a really well designed template. But it's something pretty hard to do, but it's possible to do it. I can show you here, for example, a compressor room. I think I've got a quick 3D views. No, so I don't have it right here. I don't know if you have any more. So here, for example, you have the drawing of how it can look for a bit nitrogen generation. So this one is a PDF file, but it's coming from Revit. So you can see nitrogen generators, compressors, etc., etc. And you can have different views. Yeah, so regarding importing a CAD file, yeah, it's completely possible to do it. You will need to be on the level floor, on the floor plan, either ground floor or either way, and you just go in the Insert tab, and there you've got either link a Revit file, EFC, it's a default BIM file, but you also have CIO, and there in CIO, so AutoCAD file, you can import them. Otherwise, you can go in Revit. I think there is an import. Yeah, or here you have DWF. So you just use this link in order to take them. And you can see here, by default, you have a DWG format. And once you have, because AutoCAD is made by the same company as Revit, it's really easy to draw on top of it, like walls, everything. It's gonna automatically stick to what is inside the CAD drawing. I don't see any more questions. So I'm gonna end the webinar right here. So thanks for your time and attention. I hope you've enjoyed that presentation, and you can still take my my contact right here if you've got a project, transair.quotation@parker.com, the team I'm part of. And I wish you a good afternoon, a good day if you're in North America. Thanks.